Hello, so in this experiment I am going to demonstrate for you how to carry out a titration. So a titration is an experimental technique which is used to determine the volume of one solution that's needed to completely react with a known volume of another solution. It's one of the most precise techniques that you will use when you're at school and is a key part of the triple chemistry GCSE course and also the A-level and IB courses. So it's worth making sure that you can do a titration correctly. So I'm going to talk through the equipment that you need to do a titration and how to set that up, and then I'll run through how to do a titration once I've done that. So the key pieces of apparatus that you will use when doing a titration are the burette. So the burette is like an enormous measuring cylinder with a scale that runs from 0 at the very top down to 50. Each centimetre cube division is split into 10 subdivisions, so 0.1 centimetres cubed. And at the very bottom of the burette is a tap which can control the flow of liquid. And when the tap is vertical like this, it's open. And when the tap is horizontal, it's closed. The other key piece of apparatus that we use when doing a titration is a volumetric pipette. This is slightly different to the plastic dropping pipettes that you'll be familiar with. One of the key differences is that the volumetric pipette only measures one volume. So you've got the jet of the pipette down at this end, you've got a bulb, a reservoir where most of the liquid is stored, and then on the neck of the pipette, right up here, there is a single line which indicates the volume of solution, and this pipette will measure a volume of 25 millilitres or 25 centimetres cubed, and it's accurate to plus or minus 0.06 centimetres cubed. So far more precise than using a measuring cylinder, for instance, which would have a typical uncertainty of about plus or minus 0.5 centimetres cubed. So this is a much better piece of apparatus to use. So the first thing I'm going to do is to set up the apparatus, and to do that I'm going to use a couple of 100 centimetre cubed beakers, one of which I'm going to put the acid in. So I'm going to react hydrochloric acid with an alkali sodium hydroxide. Just so I get the beakers the right way around, I'm just going to label them. So I'm just going to write HCl onto one of the beakers for the acid and NaOH onto the other one. Please don't write A for acid and A for alkali, because that will cause you some confusion later on. I also have a larger beaker, a 250 centimetre cubed beaker, which I'm just going to use for waste solutions later on. So I'm just going to pour some of the hydrochloric acid, which I've got, into the acid beaker. And some of the alkali, the sodium hydroxide, into the other beaker. It's always a good idea to use a small beaker, like a 100 centimetre cube beaker, particularly for the alkali, which we're going to pipette, just because it's a narrow diameter, which means we have a greater depth of liquid for the pipette to go into. So the first thing that we're going to do when doing a titration is to rinse the apparatus. So I'm going to rinse the burette with a little bit of acid so that any impurities in there can be washed away, but I don't want to use water because that would dilute the acid which I'm going to put into it. So put the waste beaker underneath the burette. I'm just going to pop a funnel into the top of the burette. So I've got a funnel there in the top of the burette, and I'm just going to pour some acid, making sure the tap is closed, just a little bit, just to rinse round the sides. So that small volume of acid I've used to rinse, I'm just going to let that drain now into the waste beaker. So let that flow through. Notice at the end of the burette, the jet of the burette there is filled with the acid. So I'm just going to let that run almost all out and turn that off. So really important that the end of the burette and the jet of the burette is completely filled. If there's an air bubble there, then some of your measured volume will be used to fill that, that space. So now that I've given that a rinse, I'm just going to add more acid and fill the burette to near the top. Okay, so with more acid, just pour it into the funnel, and we want the top of the liquid to be somewhere between 0 and 1 on the burette scale. So just a tiny bit more acid needed. Be careful that you don't fill the funnel with solution, because you might find that the excess volume in that funnel ends up sort of spraying over the place, and you don't want to create an acid fountain. The last thing you do when setting up the burette is to remove the funnel. There may be just a little drip of acid in the bottom of the funnel. You don't want that to fall down and change your reading. So I'm just going to pop that into the beaker with acid in, just so that I don't get mixed up between the beakers. So that's the burette filled. It's now ready to use. The next thing that I'm going to set up is the pipette. So the pipette we're going to fill with the alkali. In this case, we traditionally put the acid into the burette, the alkali into the pipette, although sometimes we might put it the other way around. To get the alkali into the pipette, I need to use a safety filler. The safety filler fits onto the top of the pipette and is used to draw the alkali into the pipette. The safety filler has an end here for the pipette to go into. It has a dial here which we can turn to draw the alkali into, or the solution into, the pipette. And then there's a lever here, which if we press the lever, air can get into the pipette and allow the level of the solution to fall, to drop. When we put the safety filler onto the pipette, do make sure you hold the pipette near the end. Don't hold it near the jet end of the pipette, because you increase the risk of twisting, breaking the pipette, and for the pipette to go into your hand. I have seen it happen. So hold the pipette at the neck of the pipette, put the pipette filler on, just turn it upside down to make sure that the filler is secure. Don't put it with the glass pointing down. Some people think that the little blue tab, you need to get the filler as far as that. You don't. So just as long as the filler is secure on the pipette. So the first thing that we're going to do is to just draw a little bit of the alkali into the pipette in order to rinse the pipette. Okay, so to rinse the pipette, just put the end of it into the alkali, just twist the dial a little bit to get a small amount of solution into the pipette. And then just by gently depressing the lever, I'm going to let some of that solution just work its way along the pipette. Be really careful that you don't completely fill the pipette, and be very careful that no solution goes into the pipette filler. So I'm just going to get some of that solution into the reservoir, into the bulb of the pipette. Just turn it round to rinse it. And then get a little bit of that solution into the neck of the pipette. Up there. And again, just rotate it round. And that solution then we can remove from the pipette and put into the waste beaker. Okay, so that's set up the apparatus. The next thing that we're going to do is to fill the pipette with 25 centimetres cubed of the alkali, and I'm going to put that alkali into a conical flask. Okay, so to fill the pipette, I'm putting the end into the alkali, twisting the dial, twisting the wheel to get the alkali drawn up into the pipette. And I'm going to draw the alkali to just above the level of the line. You can see the line on the neck of the pipette just there. Now I want the meniscus, the little dip in the solution, to just the bottom of the meniscus to just touch that line. Now you can do that by pressing the lever, but that is not a very precise way of controlling the pipette, and we see that the line is there, the liquid has gone below that. So I need to draw up some more solution, but unfortunately the pipette filler, I've got to the top of the pipette filler, so in order to be able to draw more solution up, I'm just going to place the bottom of the pipette on the beaker, going to push the lever in to allow air to go through, and just push the top of the filler down. By keeping the lever open, most of that air comes out through the hole and doesn't push the solution down. Okay, so get the level of solution up. Again, some people now control the solution using the wheel on the filler, but that's a little bit imprecise, and the level of the liquid does jump up and down a bit. I personally find it much easier now to remove the pipette filler and put a digit over the top of the pipette, and then just by very gently rocking my finger, I can allow air to come into the pipette and allow the level of the solution to fall until the bottom of the meniscus is just touching the line, and I can then transfer that under gravity into the conical flask which I've prepared. Let that come down, as I say, under gravity. Takes a few seconds to come through. And then now that the solution is nearly all out, what you might notice is that there's still just one little drip at the bottom of the pipette. So we don't want all of that to come out, but to draw some of that out, just touch the tip of the pipette to the surface of the liquid, and it draws out all but the very, very last little drop. Now the pipette has been calibrated to take that last drop into account. So what we don't want to do is to use our pipette filler to blow the solution out, because then we'll lose that final drop, which we need to keep in the pipette. The next thing to do before we start our titration is to take a reading of the volume of acid in the burette. When we take the reading, we need to read the scale down from the top, and we read again from the bottom of the meniscus. Okay, so to take this reading, what I generally do is put my finger just behind the burette and below the top of the solution, and I get a shadow of my finger on the bottom of the meniscus, and then can read the scale. Now with the scale, you can read to 2 decimal places. The second decimal place will either be a 0 if the bottom of the meniscus is just touching a line, or if the bottom of the meniscus is between 2 lines, we can give a reading of the second decimal place of being 5, so halfway between 2 lines. Now, for this particular one, the meniscus is just on 0.4 centimeters cubed, so my reading will be 0.40 centimeters cubed. And I'm going to record that in the form of a table. So on my table, I'm just going to record the volumes for the burette readings. Traditionally, we put the final reading in centimeters cubed, then underneath that, the initial reading in centimeters cubed. We can subtract the initial reading from the final reading to give the titer. The titer is the volume of acid that we added to neutralize the alkali. And we will repeat this several times. The first reading that we'll do will be a rough reading, just a rough titration just to get an approximate volume, and then we'll do some more accurate readings. If you're doing IB, it's a really good idea to record the uncertainty in the reading on the scale, in the table, and the uncertainty in each burette reading is plus or minus 0.05 centimeters cubed. The uncertainty in the titration is normally given in an exam as being plus or minus 0.15 centimeters cubed. So 0.05 for the initial reading, 0.05 for the final reading. And then we also generally at A level allow a 0.05 for the final drop at the end of the burette. So my initial reading there was 0.40 centimeters cubed. No need to record the unit in the table because the unit is already in the heading for that row. So the last thing I need to do now is just to add about 3 or 4 drops of indicator. I'm using the indicator phenolphthalein, which has a pink colour in alkali and is colourless when it's been neutralised. So about 4 drops of the indicator, and just swirl that. And the apparatus is now ready to use and to do a titration. Okay, so to do the titration, I need to put the flask under the burette. So I'm just going to slide the burette up just a tiny bit, put my flask underneath the burette, and then add some acid. Now, when using the burette, some people use the tap like this and just hold it between their thumb and forefinger. Some people tend to put the tap on the other side of the burette and just rest their hand on the burette and use the tap just to open and close like that. I personally find it more comfortable to use the burette like this. And we can see that that's already gone, which tells me that the acid is really quite concentrated compared to the alkali, the sodium hydroxide. So recording a final reading for this titration, we have a reading of 5.40, which means our titer in this case is only 5.00 centimetres cubed, which is very, very small. Okay, so when the titration is finished, just take the solution out of the conical flask and put it into your waste beaker, and then use some distilled water just to rinse the flask 2 or 3 times. And then you're ready to do the next titration. So let's check you've got enough volume of sodium hydroxide. I'll just add a little bit more into there. Because the titer value from the rough titration was so small, I don't need to refill the burette. So take the pipette and draw up another 25 centimetres cubed of the sodium hydroxide. Get the meniscus down to the line and transfer to the flask. You'll know you've rinsed the flask properly if there's no residue of indicator in there, so it won't go pink from the indicator. Again, let it empty under gravity. And just touch the tip of the pipette to the surface of the solution. Put the pipette down, add some indicator. Don't add too much indicator because most indicators are themselves acids, and so they can also be involved in the reaction. So we don't want to add loads of indicator into our flask. Just check the reading. So that's 5.40 centimetres cubed. So where the last titration ended up. And this time, I know it's going to be a small volume, so I'll just add a few centimetres cubed. And I'll add the acid more slowly. And then near the end point is when the indicator changes colour. I can adjust the burette so that I can get just a drop of acid at a time. Once the indicator is on the verge of changing colour, I can just add some distilled water just to rinse the sides of the flask, make sure all the solution is in the flask. And ideally what we want is just one drop of acid to cause the indicator to change from that pink colour to colourless. I'm going quite slowly near this end point. Still a very, very pale tinge there. Let's just rinse the solution in. Gone. So take the reading, and we've got 9.55. So that gives a 4.15 centimetre cubed titer reading. That's a bit more than we had for the previous titration, so I was taken by surprise. So again, rinse it through once, twice, 3 times. Take a little bit more sodium hydroxide. And so fill the pipette again. By this point you'll be getting quite proficient at using the pipette and pipette filler. Get the meniscus exactly onto the line. Transfer. Don't be tempted to add the indicator at this point to save yourself some time, because that will contaminate the tip of the pipette. We don't want to contaminate that. And again, we can't hurry it out. Touch the tip of the pipette to the surface of the solution. Now we can add our indicator. So just a few drops of indicator in there. Check the reading again. So 9.55 again. So I know I'm aiming for about 4 centimetres cubed. So if I just add down to about 13, give that a swirl. Add a little bit. So because we've got such small titer values, I don't need to add any more acid into the burette. Again, that's gone very pale. So we're almost at the end point. Patience always needed just near the end point. Almost there. And And there we go. So that is reading at 13.70, which gives us 4.15. So I have two tighter readings which are exactly the same. And so those two readings are what we say concordant. They're the same as each other or within 0.1 centimetres cubed. So I can then calculate an average value from those two. And that's the method for how to do a titration.